Hello students, today we are discussing the topic solid state, that is in class 12. Now we are discussing the further solution of NCERT. We have already discussed question number 1st, 2nd and 3rd. Now today we will discuss question number 4th. So the topic is solid state. So is the NCERT problem. Now we are discussing the problem number is 4. That is what is meant by term coordination number. What is meant by term coordination number, that is CN. It's a coordination number. We are discussing about the coordination number. Then the coordination number of an atom in a crystal is the number of atoms which are the immediate neighbors of that atom in the crystal. For example, we are taking the ionic crystals. Coordination number of an ion in the crystal is the number of oppositely charged ions surrounding that particular ions. So in short, the coordination number means number of nearest atoms touches to each other. For example, if we are taking a simple example, like we are having the spheres. Now when we are arranging the spheres in 1D, so the arrangement of these types is the simple arrangement of the spheres in the solid state. Now this is the 1D arrangement. Now in this arrangement, the middle sphere, any one middle sphere touches with the two spheres. So we are saying that this middle sphere having coordination number 2. And coordination number always decided with respect to middle sphere. So this is, now we are saying that in the 1D, always coordination number is 2. Now if we are discussing about 2D arrangement, so there are two possibilities for the 2D arrangement. For example, this is the first or 1D arrangement when sphere touches to each other. Now if we are taking the second layer, then there are two possibilities. According to first possibility, the second layer placed parallel to the first layer. This type, this one is the third layer. But each layer is parallel to each other. Now, if we are taking any one sphere which is in the middle, like this. So we are saying that this sphere is surrounded with the 4 spheres. That's 1, 2, 3, 4. Means this middle sphere touches with the 4 spheres. They make a square. So this is called square close packing, or we are saying that here is the coordination number of this middle sphere equals to 4. So in the 1D arrangement, coordination number is 2. This is the 2D arrangement where the coordination number is 4. Now another possibility in 2D arrangement. Suppose this one is the first layer of the sphere. If we are placing the second layer, then if second layer placed between the dispersion of these two spheres, and third layer placed parallel to the first layer. Now we are taking the central atom. This one is the central atom, red dot. Up this central atom surrounded how many atoms, or directly touches to how many atoms? This one is the 1, 2, 3, 4, 5, 6. So in that case, we are saying that the central atom is surrounded by the 6 spheres. So we are saying that cross spheres having coordination number 6. So this types of 2D arrangement, here is the coordination number equals to 6. So we are saying that if we are taking 1D arrangement, the coordination number is 2, and if we are taking 2D arrangement, there are two possibilities. It may be coordination number 4 or 6. Coordination number 4 is square making, and the coordination number 6. It's making a hexagon. Now the second part of this question number 14. What is the coordination number of atoms? What is the coordination number of atoms in cubical closed packing structure, CCP structure, and second is body centered cubical structure, that is BCC structure. Now the cubical closed packing having a structure of this type. Now in this arrangement, the 2D arrangement, this sphere is surrounded by the 6 sphere. Now we are converting into 3D arrangement. Then what actually happened? This middle sphere or cross sphere, its all layer 6 sphere attaches to each other. But in the 3D arrangement, 3 spheres are above to that sphere and 3 spheres are below to that sphere. So in the CCP, the coordination number, it becomes 12. 6 spheres are on its layer. 3 spheres above and 3 spheres below. This makes the coordination number 12. Next one is the BCC. In the BCC, coordination number equals to 8. Since in the BCC structure, we are making a cube. In the cube, these 8 spheres are at the 8 corners. Here is the 8 corners which represent the 8 spheres. And the one sphere that is placed the body centered. Now this body centered sphere in the BCC structure touches to the 8 spheres which are placed to each corners. Like this type. Started from this, this, now this one, this one, this one, this one. So the center atom touches with the 8 corner atoms. Hence its coordination number becomes 8. Now the next question number 5. How can you determine the atomic mass of an unknown metal? If you know density and the dimension, if you know density and dimensions of its unit cell, let density equals to D, gram per centimeter cube, and the edge length equals to A centimeter. Now volume of the unit cell equals to A cube, centimeter cube. Now as we know that density equals to mass upon volume. Now D equals to volume means A cube. Now what's the meaning of M? M is mass. Since the mass means number of atoms in unit cell into mass of each particles upon A cube. Now by the using of this formula, we can easily decide number of atoms in unit cell, that is represented by Z. As we know that number of atoms, that is the Z, into mass of each atom like small m upon A cube. Now the problem is that how we can decide the mass of this. So as we know that 6.023 into 10 to the power 23 atoms equals to molar mass of any atom. Therefore, one atom equals to molar mass, molecular weight upon this Avogadro number. So if we are using the formula, density equals to Z into small m upon AQ. Now we are using molecular weight upon Na in place of this small m. So here we are having the formula Z into small m means molecular weight upon Avogadro number into AQ. By the using of this formula, we can decide the molecular weight of any single atom. So if we are knowing the density, age length and number of atoms, now by the using of these three, since Avogadro number is always constant, we can decide the molecular weight of any atom. Thus the value of Z depend upon the types of unit cell. If we are taking simple unit cell, in the simple unit cell, Z becomes 1. If we are taking FCC unit cell, face centered unit cell, then Z becomes 4. And if we are taking BCC, body centered, then Z becomes 2. So we are already having the idea about the Z and the density and the age length and NH. Avogadro constant, that value is always constant. Now if we are knowing about these 4 parameters, then we can calculate the molecular mass of any atom.